Yeah, so I'm Jonathan Lundgren. I'm a beekeeper. I'm a farmer. I raise lamb, honey, cut flowers. Christina raises. We have a diversified farm called Blue Dasher Farm, and then I also do some science, and that's what I want to be talking about a little bit today is some of that science that we've been running on this concept of regenerative agriculture, particularly in North America, but we're hoping to globalize it, and so maybe there's some things that we could talk about with that. Um, right, I was in Florida. How many? Yeah, a lot of you probably, well, maybe some of you have been to Florida, huh? It's warm, it's sunny. No, maybe not. It's warm, it's sunny in the United States and in many places. You know, it's known for two things: Walt Disney World and oranges. Um, and so much of the nation's citrus comes from this little panhandle in the ocean. And but what they don't know is that most of the citrus industry has actually died. It's at 4% of its normal production. And they're blaming a disease for that. Um, but I think that if we really wanted to solve this problem, we're going to have to look a little deeper in the mirror. Um, and so you could see the remaining trees that are left have cans of antibiotics that are being injected into the trunks. But if you look beyond that can of antibiotics, you see beach sand. And that was once rich soil, forest soil that they turned into beach sand through their agricultural practices. And I was speaking with one of the farmers, and I said, there are farmers in Florida that are bringing their orchards back to life. And one of the tricks that they're doing is they're planting vegetation from trunk to trunk, from tree trunk to tree trunk. And he said, you know, if that's true, then that's flying in the face of everything we're being told by the universities and by the citrus industry. And I asked him, how's that advice working? How is it working? And he thought about it for a second, and he said, yeah, you're right. They're not looking out for us at this point. We're yeah, it's not getting better. And there's a problem in agriculture right now. And the problem is on this slide. It is not soybeans. It is how those soybeans are being produced. And agriculture and our perception of food production has become far too simplified. Certainly in North America, but basically any area of major agricultural production with large flat areas tends to suffer the same fate. Much of the biodiversity that used to be there has been replaced with a monoculture of a particular crop species. And when you eliminate a lot of the biodiversity from that habitat, you have to replace it with something and in order to keep that habitat productive. And so that's where a lot of our agrochemicals come in. Jugs, jugs is what I call them. Be that chemical fertilizers, insecticides, herbicides, fungicides, all of them do one thing, and they replace what biodiversity used to provide to us for free. And and there's unintended consequences of that. Um, Corn seed, so maize production in the United States, corn production is one of the dominant landforms at this point. It's become one of the largest biomes in the continental United States. I believe about 9% of the terrestrial land surface of the United States is now two plant species, corn and soybeans. And those corn seeds, when we plant them, they're covered, they're every color of the rainbow. And that's not the way they're grown. They're treated. They're treated with things like neonicotinoid insecticides and fungicides. And those pesticides were intended to reduce the amount of pesticides that are entering the environment. The problem is that they're very, very toxic. And so the seed then germinates and it takes the insecticide and fungicide into the developing seedling. And the intention is that it protects that young seedling from early season herbivory. The reality is that, between 90 and 97% of that insecticidal seed treatment doesn't go into the plant. It goes into the environment. And some of these toxins that we're now applying to our corn seed or soy, most of our field crop seeds, are some of the more toxic pesticides known to man. One seed of corn is planted, it has enough insecticide to kill about 164,000 bees. So very, very highly toxic. And there's unintended consequences of that because insecticides don't just kill insects, right? I had a friend of mine, she lives in Montana. I hail from South Dakota, for those that don't know it. It's on the Canadian border. We're in the frigid north. And Montana is west of us. And she said there was some interesting things that are going on with the deer in her area. That 70% of the deer that the hunters were harvesting had jaw deformities like the one you see here. And they also had, in the males, about 70% of them had genital deformities, which they really hadn't been experiencing before. And she was wondering whether or not it might be possible that the neonicotinoid seed treatments that were going on much of the grain seed in their region might be affecting these deer. And so my graduate student, her name is Elise, she tried to tackle an experiment. It was a very, very difficult experiment and one that will never likely be repeated again, simply because of the challenges. She fed captive deer neonicotinoids and then measured the fitness response of those animals to over 2 generations. So a very challenging study to run. What she found, imidacloprid is the neonicotinoid. It's a very common one for those of you that don't know it. One of the dominant neonics that's out there right now. We measured a lot of different body tissues of the animals to see which of those tissues seemed to correlate well in terms of quantity of neonicotinoid within that organ tissue and how it affects the fitness of the animal. And so the spleen happened to be a really good indicator organ. So the amount of neonicotinoid in the spleen of dead fawns was substantially higher than what we found in live fawns, which gives us some suggestion of causation. We looked a little bit further. So the more imidacloprid that we would find in the spleens of these animals was associated with reduced body weight in the fawns. They were smaller. Reduced organ weights, that's not surprising. Those animals were smaller. They had disrupted fawn thyroid hormone levels. And that one's an important one. There's hyperthyroidism that's blowing through North America at this point, and within humans. And I think it's time for us to start connecting the dots there. I know at least 2 people on our staff that have this issue, where their hormones are just being really messed up. Fawn jawbone lengths were affected, just like we saw in the wild. And then the activity levels in these adult deer were substantially slower. They were lethargic. Okay, what's a slow deer in the wild, right? It's a dead deer, right? They don't do as well, do they? And so all of these things, if I was to replace the word fawn with honeybees, or if I was to replace the word fawn with humans, we're finding very similar patterns that we found that we were able to generate in these deer by giving them insecticide. Okay. So in the laboratory, or in this experimental scenario, we were only able to maximally force feed these deer up to 0.18 nanograms of imidacloprid per gram of spleen. That was the most we were able to register with our, and that seems okay. That's a lot, right? But and what are they actually being exposed to in the wild then? And so some friends of ours with the Game, Fish, and Parks Department in North Dakota, which is right on the Canadian border, sent us a bunch of hunter-killed spleens of these deer, and we tested those. They had 3 times the amount of what we were able to generate. What are we doing? What are we doing to the environment? What are we doing to ourselves right now? I think this is going to be this is the battlefront of our generation. The human race's current trajectory and the natural world's current trajectory is going to depend on our behavior over the next couple of years. Back in 2022, there was this thing that was getting started in the US. At least it was becoming a little bit more, it was gaining steam. Regenerative agriculture. And it was in part in response to some of these, overuse of pesticides and things like this. There were farmers that were telling tremendous success stories about the potential of what our food system could do in terms of solving some of these planetary scale problems. And some of those were featured in Root So Deep, right? Those ranches. And there was potential. If this was real, then there was global food policies and tremendous investment potential that could get behind this. But there was this question that was stopping it of, is this real, right? Why should we trust these farmers? And I was working on our own farm in South Dakota and kind of wondering what was next for ECDYSIS Foundation and our initiative, if we were supposed to be helping to usher in the evolution of a regenerative food system. Well, science might be able to help to answer that question. And so we were sort of forced into, number one, is it working, right? Our current system, is it working? This is a dust storm right down the street from my house 2 years ago, the likes of which we haven't seen since the 1930s in North America. It doesn't seem like the traditional status quo was working very well. So this was gaining attention, okay, that these farmers were doing this, and we had to ask ourselves, okay, what would a project, if science could help, what would that look like? And I think that essentially if we were to run a scientific experiment to try to see whether or not, or measure whether or not regenerative agriculture works, it was going to have to be big, and it was going to have to happen fast, okay? Because there's a sense of urgency right now. So it had to simultaneously examine every cropping and livestock system in the United States. It had to simultaneously look at all of the ecoregions of the United States. It had to reflect farmer-developed best management practices, because scientists were never meant to be the experts on farming. They were meant to be servants of farmers. And we were going to have to simultaneous with all of that geographic parameters, we were going to have to measure all of the different regenerative outcomes. We couldn't just focus on carbon. That doesn't tell the story. And then we also had to probably develop entirely new tech in order to be able to do this, because current technologies are not adequate for measuring a continental scale food system at scale like that. And so that is, and then we had to ask the question of who's the best people for the job. And I don't know that we're not the prettiest, we're not the smartest, we're not the richest. That's for damn sure. Um, but for some reason, we attract people that really want to make a difference. And so no one else was jumping into this, and we thought maybe we could help. And that's what Thousand Farms became, was this attempt. So this is from 22 to 24, and I have a new map. I wish I had put that up here for 2025. The blue dot or the blue triangle is headquarters. That is Blue Dasher Farm. So you kind of get an idea of where we're at. And then so far, over the last 4 years, from that blue triangle, we've deployed scientific teams to 1,700 farms across North America. And we're trying to make this map ultimately be a reflection of the continent's food system. Okay. And so this year we're filling in the gaps, you know. For those of you, I don't know if you have the game Risk in Sweden or not, but it's this is a game of Risk on crack cocaine, right? I mean, it's like, okay, how do you expand using limited resources, expand the battlefront while maintaining the relationships that we forged where we've already been? And it's a real, there's a reason nobody's ever tried to do this before, right? This is really hard. And yeah, we kind of cobbled together this thing over the last 4 years using this sort of ragtag group of maverick that wanted to save the planet.
Can I just ask, is that like, oh yeah, you're coming to that. I was just wondering what type of systems that they're running, but yeah, seen that
Yeah.
that.
So each of those dots, we actually have to give a score. And they fall along a spectrum from very, very conventional to very, very wacko regenerative, right? And we developed a very simple scoring system that in about 2 minutes, I can ask 8 yes or no questions to a farmer, and I can place them along this spectrum. And I can make pretty damn accurate predictions as far as what we're going to find there in terms of organic matter in the soil, and how many insects we're going to see, and how happy you are, and whether you have Parkinson's in your family. It's a fantastically predictive. I mean, we put $1 million into this thing, right? So, and it's the only scoring system that I've seen to date that's actually been empirically backed, and it's free. So, this is what it looks like for croplands. Basically, the most regenerative farms, and these weren't meant to be buckets, okay, of practices. These weren't meant to be the outcomes, okay. What these practices ended up being were proxies of a regenerative mindset, of a management philosophy. And I think that that's really important, because if we make this into a box checking exercise of which practices you use, then regenerative ag is never going to be able to attain what's possible. It'll get screwed over like organic did, in the US at least. And then on each of these dots, each of these farms, we measured things. Okay, so we measured biodiversity. We named all of the microbes, bacteria, fungi in the soil. We've actually created the largest bioinventory, I think, of agroecosystems that's ever been created. We named all of the invertebrates. We named all of the birds, all of the plants. About 14,000 species we've counted so far, and that's on the low side. And then we also measured things like Okay, so what's carbon capture and storage doing out there? Methane production and stuff from soils. Water. Can this reduce desertification or reverse it? Nutrition. Can we, this is one of the more comprehensive examinations of phytonutrients that's ever been conducted before. We're partnering with the American Heart Association and a company called ECDYSIS that's measuring comprehensive nutrient profiles of foods. 16,000 phytonutrients we're quantifying on each yield sample, of which we humans only have names for 400 or something like that. So this is pretty in-depth. And then we're looking at pollution. You know, how much are you using out there, right? Profit, and then farmer wellness and mental and physical wellness. It changed my perception of what a regenerative farm does and what it is. And I think that the first is that regenerative agriculture fundamentally, unavoidably celebrates life in all of its forms. And so this is regenerative rangelands. It's about 250 ranches that we sampled, and we measured all of the birds and the insects and the fungi, the arbuscular mycorrhizal fungi were significantly increased. What those black dots are is the percent increase in the regenerative ranches compared to the conventional ranches. So you see that there's, you know, doubling, tripling of each of these biological groups that we've measured. That's really important, okay? I was on a Amish farm in upstate New York, and I was speaking with the farmer. That's an important part of what we do, is just listening. And in this case, I was telling him all the things we were measuring. And I was like, yeah, we're going to tell you about all the carbon that we're measuring down to 60 centimeters at different stratus to see how things are changing within your soils as far as carbon capture and storage. And he kind of nodded. He's like, okay, that's great. And then I said, and then we're going to measure the water and how that's interacting with your soils and whether that soil is holding that water or letting it in when you get a rainfall event. He's like, okay, yeah, that's great. And then we're going to name all of the bacteria in your soil. And his eyes got a little brighter. And I said, and then we're going to name all the fungi and the insects and the birds and the plants. And that really resonated with him. And I asked him afterward, why? Why did that resonate so strongly with you? And he explained to me that as part of his faith, humans, farmers especially, but humans were meant to be stewards of life. And of all of the other scientific teams that were coming out and measuring things on his farm, nobody was telling him about that. And that was really interesting to him and to me. And I think that it sets this study apart because that life, all of these other outcomes, right, of a regenerative system, social resilience, economic resilience, water cycling, carbon, you know, and greenhouse gas production, those are the outcomes of biodiversity. Okay, biodiversity is what produces all of those things. And if we measure those things instead of biodiversity, cheaters come in. We end up getting a lot of people that say, okay, well, if carbon's the goal, do I have the magic elixir for you? Right? And they're building pipelines across North America to take corn-based ethanol and shoot it into the ground as a way of a carbon mitigation strategy, for an example. This is ridiculous, what we live in. In order to measure that life, we've actually had to develop entirely new tech. And that new tech isn't Cassandra. That's a human being right there. But what she's looking into is what she's doing is that she's imaging, and not just her, poor her, but 1.3 million specimens of insects. And then we've developed artificial intelligence to be able to identify those insects. And we will create, so it's about 80 to 90% accurate on several thousand species now. And we're going to be giving that away. So farmers at the end of this, once it's trained up for your particular region, you should be able to go out with a sweep net, for example, sweep some bugs, take a photograph of it. Bugbox will take that photograph, it'll pixelate it, it'll separate out all of the insects, and then it will identify each of those insects for you, creating community level things. And we can use that bioindicator of invertebrates as a really good bellwether of a lot of the other biological, physical, and chemical aspects and social aspects of the farm. Similarly, we're putting in each of these fields a data recorder, a little sound recorder, and recording all of the bird song and other biological noise that's going on in the field as a different, we're calling that syrinx. And then we're also, if you're, for example, if you've got microbial data, we really need to be sequencing a lot of this stuff, and that gets expensive, and there's companies that are evolving in order to fill that, right? So you can take a soil sample and you can get it sequenced, and they'll tell you all kinds of microbes in it. A lot of that's interpretation of the DNA, the microbial DNA is kind of behind a paywall. And so we're developing an open access source so you can input your sequence data and it'll interpret it for you and help it easier, make it easier to understand. Give you some indexes of what's happening out there. So new tech is a really important part of this whole process, right? Because the way we've been doing this, just, yeah, I mean, we can't, there isn't the taxonomic expertise out there anymore to identify millions of specimens of insects, for example. And getting an ornithologist to each of these different farms, that's a real struggle too. So you get the idea. Okay, so one of the regenerative outcomes, the things it's supposed to do is fight climate change, right? It's supposed to be a really important answer for that. We measured carbon. Okay, we measured carbon, deep carbon on these soils. And this is for croplands. This is row cropping systems in North America. So this is corn, soybeans, wheat, canola, those kinds of things. Each of those bars, think of that as a soil column, okay, that was divided into 5 categories at 5 depths. And that's the amount of carbon that we found in the regenerative soils versus the conventional soils. There's a couple of things to unpack with this graph, okay, and it's a busy one, so sorry for that, but it's hard to represent ecological data simply sometimes. Number one, the regenerative bar is higher than the conventional bar. By 40%, there's more carbon in those regenerative soils, okay? That's important. Next is that it's not just, so science says that carbon is generated in the top tier of soil, those top 3 layers of soil is where most of the carbon is generated because that's where most life is in soils. It's in that top 6 centimeters, 15 centimeters, I'm sorry, 4 inches. And so what this graph is showing us is that, and the problem with that type of carbon is that it's fragile. I mean, if you go through and till right after that carbon capture and storage, it just goes back into the atmosphere, right? It's very labile. What this graph shows is that regenerative croplands actually put that carbon very deep down into the soil where it's recalcitrant and it stays. That's important when we're thinking about some of these models for predicting the potential of regenerative agriculture for combating soil soil problems, or I'm sorry, climate problems. The end result is that if we were to convert all of the nation's croplands over to fully regenerative practices, it would store the equivalent of 2 years worth of annual emissions. That's huge, okay? And if you were to actually include the rangelands and convert rangelands over to fully regenerative practices, that means keeping animals tight, moving them frequently, and letting it rest. That's an additional 5 years worth of annual emissions. And so those animals become an important part of the tool for sequestering and storing carbon. 7 years worth of annual emissions. When you look at the alternative technologies that are being proposed for mitigating carbon and greenhouse gases, the results and the potential results of those are laughable compared to what our agroecosystems can do, while generating more life, while reversing desertification, while correcting social and health problems. It's a pretty powerful solution right there. Okay, one of the other outcomes that regenerative agriculture is supposed to do is reduce pollution. This was data from, so in some of the areas we've visited, this happens to be from Washington, the state of Washington, which is out in the Northwest. They grow wheat and lots of it. We actually revisited some of these wheat farms as they went through a regenerative transition. So over 3 years. And we have identical data from the Plains region of Canada, so Manitoba and Saskatchewan. Over that period of time, 2/3 of the regenerative farms eliminated all synthetic fertilizers and all synthetic herbicides. 90% of them eliminated all insecticides and fungicides. Think if we were to scale that, the environmental footprint that we would be correcting with all of that agrochemical use. That's huge. And if these farmers went down to the local co-op where they get all their seed and supplies and things like that, they sure as hell wouldn't get that story, would they? They'd be given the bag of jugs or the box of jugs, right? And told, so-and-so lives down the road from you. I don't know, he didn't spray this year and he lost it all. I wouldn't take it. I mean, it's only a few bucks an acre. It's insurance, right? Yeah, right. Water. California, the Central Valley of California is in collapse right now. This is one of the most important agricultural regions. It's, I think, the largest, second largest agricultural economy in the world is in California. And the Central Valley began as a wetland, and they turned it into a desert. And now land prices are plummeting because they don't have any water left. Regenerative. This is also where they happen to grow 90% of the world's almonds are from the Central Valley of California. And every one of the nuts, each almond, it takes 2.5 liters of water to grow each nut. Isn't that crazy? What we're finding is that these regenerative almond producers are able to reduce the amount of water that they're using by between 30 and 70% without sacrificing yields. That's huge. That would recharge the aquifer in Central California. So this can be used even within crop production to help to reverse desertification that's caused by poor practices. Regenerative agriculture is supposed to grow more nutritious foods. and we're going to be producing a lot of this data over the next few months. But we just ran the first analysis on wheat from Washington that I was telling you about. And in this case, the regenerative producers doubled the amount of protein in their wheat and increased significantly quite a few of these other micronutrients that we were measuring. And we're hoping to be able to resolve that a little bit deeper. One of the problems I think that we're facing is that we don't really know what a nutritious food is. And so we can tell you based on environmental characteristics or management characteristics that zinc went up. Oh, and I spelled zinc wrong there. Sorry about that. And sulfur went up. Is that good? I think the nutrition world is going to have to play catch up here. And this study, I'm hoping, will provide a basis at least for helping to interpret some of these things, such that when the nutritional science world can decide, okay, well, you need this ratio of iron to copper if you've got this genetic profile or something like that, then at least we'll be able to say, okay, well, regenerative agriculture does that, But in the meantime, yeah, it's a little bit of a leap of faith. Does regenerative agriculture increase profit? So yes. Number one, can we feed the world, right? That's assuming you're going to go down to the grain bin and take a handful of grain corn and take a bite, right? Nobody eats corn and soybeans. If we really wanted to feed the world, we would grow food, not commodities like that. But here we are. Our data is clear. I mean, you produce the national averages with regenerative production. You're not producing less than the national averages. So yeah, we can feed the world. In fact, it's probably the only way we'll be able to feed the world. Interestingly, because this was best management practices, the conventional farmers produced more yield, but they paid a lot more to do it, such that net profitability was equivalent in these two systems. And the maximum profit and productivity within these different row cropping systems that we measured was actually oftentimes it was the regenerative farms that were attaining those high levels. The problem is that the lowest ones were sometimes regenerative too. And it really begs the question of what is driving that? Is that an environmental characteristic? I don't think so, actually. I think it's a social one. They are prioritizing other currencies within their systems. And identifying those and teasing those out is going to be extremely important for understanding the true potential of regenerative ag. Does it make us healthier? I don't have the answer to that yet, but I think I do. Anyways, okay, so we asked croppers in the US whether they had experienced any of these autoimmune diseases, mental health problems, or physical ailments. 41% of the croppers had allergies. A third of them were anxious. A quarter of them were self-reported as clinically depressed. Okay. And then we looked at society at large, not just croppers, but everybody in the United States. And these were the numbers that we found. In terms of increase in our croppers over that baseline of society. 3 times the depression rate, double the asthma in our croppers. 3 times the cancer rate, 2,000 times the Parkinson's rate. We're killing our farmers. We're literally killing our farmers for corporate greed. I was in Napa, which is one of the most prestigious wine growing regions of the United States. Some of the richest people on earth live there. Yeah, the land goes for $1 million an acre for mature vines. But climate change is happening and it's shutting the vines down. So the whole industry is having to move north. Um, and I was at a conference there, and one of the farmers got up there and said, I did an experiment on my farm to look at ground cover management. And what we found was that we compared mowing and herbicides and grazing with sheep, which one of my grad students was working with sheep. And she said the results of this were really interesting. They all were equally effective, but the Roundup, the glyphosate the herbicide that we sprayed out there was the cheapest. And so that's probably the way to go. Uh, I got up afterwards. They gave me 5 minutes, and I'm like, yeah, well, to hell with that. And the first question that I asked them was this: at the end of your life, you're going to look your spouse in the eye, and you're going to have to say, I'm sorry. I was trying to save some money. I heard that these agrochemicals were hurtful to us, but I didn't believe it. It didn't affect me. And now our grandkids are sick or dead. And I'm sorry. Does that cut it? Let's walk this one down the chessboard a few moves here, folks. Was that money worth it? I think we need to reprioritize our values here, folks. So is regenerative agriculture real? Yeah. Yeah, it is. But it works differently than I thought. And that's been one of the beautiful things about Thousand Farms Initiative is that this is one of the first times in human history that you've gotten a single scientific team that has intimately studied a continent's food system before. And not just through a certification program or something like this, but actually gotten our hands dirty and gotten calluses on our hands, right? And that's exposed us to a food system in a way that really has enlightened me about the potential of what we can be expecting. I used to think, and there's a lot of certification programs that are evolving right now that are going to be, all right, did you plant cover crops this year? Did you no-till? Did you incorporate livestock? And check this box. Check, 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 check. Oh, certification. Stamped, right? It's regenerative. I think one of my friends up in Canada, he's trying his best to do the regenerative thing. And he was given a free certification by one of the companies who's trying to get a leg up, right? And he's like, John, this doesn't feel right to me. I'm growing my regenerative grain up here in Canada, and I'm shipping it to a regenerative chicken plant in Fresno, California. And all of it's certified. I was at another meeting and I served on a panel with a farmer who worked with a major dairy company who is the token regenerative farmer at this business meeting. And I'm like, oh, I'm so glad to meet you. What do you do? Yeah, what's your farm like? And he's like, oh yeah, we've got a family farm, a family dairy operation out in western Nebraska, which the Ogallala aquifer, which fed most of western United States, is dry. They mined it dry. And I'm like, oh, okay, well, that's awesome. You got a dairy out there, family dairy. And he's like, yeah, we milk 20,000 head. I'm like, boy, that must be a big family, right? Um, we're at a real risk of losing the sense of what regenerative agriculture is. And this is my definition fundamentally of what regenerative ag is now. A regenerative farmer, number one, farms smaller and better. not bigger and simpler. Okay. There's a lot to unpack with that. That means we need a lot more farms on the ground, farmers on the ground. That means that we need to change our identity as a farmer and what is a good farmer from one that has accumulated land, right? They bought the next quarter of land next to them. That means I must be doing things right. I got the fanciest truck in the neighborhood. I must be doing things right. Human feet touch every acre of their farm. I was riding with one of my scientists and he stopped the van and he pointed at a soybean field that was next to his house in Minnesota. And he said, John, that field was tilled. It was sprayed with herbicides. It was planted. That seed had insecticides and fungicides on it. It was sprayed with herbicides again. It had a fly on of herbicides and fungicides and insecticides. It was harvested, it was tilled, and it was sprayed again. Human feet haven't touched that piece of ground. That's not farming. That's mining. We have to be connecting with the land and our food. That's so important right now. Number 3, regenerative farmers grow food. They grow food for their families and for their communities. It's not a commodity that they put on a rail car and ship across a continent to ship to some other country, right? Food production has to start locally. And yeah, that means a really important change in society where we repopulate some of these rural areas rather than the other direction. I think that's already actually happening in the US quite a bit. A lot of money came in on the coasts and now it's getting dispersed throughout the country. Might be happening in Europe too, I don't know. I was talking with a farmer in New York, or I'm sorry, North Carolina. And he was a blueberry farmer. Blueberry farmer. He also grew muscadine grapes, which is a type of grape, table grape that is native to North America. And he is a soldier, and so he thought very, yep, it was a tight ship, and I asked him what it was like for him to sell his blueberries, because I was eating them by the handful because they were just delicious, right? I mean, and so I'm like, what's it like for you to sell these things at the market? And I don't think he had put it into words before because he thought about it for a second, and he's just like, it feels so good to be able to share something that I've grown. And to tell those people that these blueberries are safe for their families, that they don't have a bunch of chemicals all over them. Yeah. Another farmer up in Vermont articulated something that I've been feeling really well, or feeling a lot right now. She said, who the hell came up with this idea that we should commoditize something as sacred as food? Right? Does food production fit within traditional capitalistic economic models? I'm not sure that it was ever really meant to. Yeah, that doesn't mean I'm saying farmers shouldn't be able to make money at their farms and stuff like that, or people shouldn't pay for good food. But I also think that farms and food, I mean, within the US, there's this imposter syndrome. Like, if you are not generating every dime for your family off of the farm, that you're an imposter, that you're not a real farmer. That's bullshit. Okay? If you're growing food, if you've got a freaking herb plant on your windowsill, you are a farmer. You're growing food and you're sharing that food. And that farm is meant to provide a lot of other currencies. It's meant to provide the basis of family. It's meant to provide the basis of community, a diverse and healthy ecosystem. And those are just as valuable as economic currencies. We really need to value that higher within our society right now. And then finally, a regenerative farm celebrates life, all of its facets. All right, I'm going to stop there. What time is it? How am I doing? I didn't do too bad. All right. I could talk for hours here.